This video is going to look at synclines. Synclines are layers of rock that over time have been compressed, and instead of arching up like the anticlines did, they sink down. So you can see from our diagram that we start out with the oldest on the bottom, the middle layer, and then the very youngest layer on the top. That's a standard ordering for rock layers, oldest on the bottom, youngest on the top. For a syncline, we're going to let the compressive forces push in, and it will cause the rock to sink in the middle. We'll have one on the bottom, but now we've got this U-shaped configuration. If we allow erosion to come along and eat away, it could be a glacier dragging the rock away, a river floods the area, or again, I could have a bulldozer. What would happen is that we'd have one on the outside layers, two adjacent to it, and three in the very middle. We're going to go back and use our layers of Play-Doh, whoops, get them turned the right way, from the anticline example where there's the pink on the bottom, the purple in the middle, and the green on top. The green being the youngest and the pink being the oldest layers. So if we add those colors so we can keep it straight, again, the hot pink is the oldest in all of these situations. So it'll be layer number 1. And the green is the youngest. It'll be layer number 3. And then finally, the purple is in the middle. Again, you don't have to color them. You do need to number them, though. The numbers are really important for us. 1 will be the oldest, and whatever your largest number is will be the youngest layer. All right, so to make a syncline, we have to take our Play-Doh, and instead of arching it up, we sink it down. So if I do that, it looks like this. Again, kind of like a taco. I will put the cutting board in place so I can anchor it. And use my string to erode it away, and we will see what we end up with. So you can see that we have a pattern. We have the green in the middle, that's the youngest, purple on either side of that, and the very outside edges of the hot pink, that corresponds to the oldest rock. So if we take our drawing and put in the correct numbers, so again, on the outside was the oldest, so that has to be layer 1, followed by layer 2 next to that, and then layer 3. I've learned, because it's a pattern with a regular shape, I'm going to draw a dashed line through the middle of it. That will make it our central axis. I see I've shifted my paper, so we'll push it up just a little bit. That'll make it my central axis. And now we want to draw in the strike and dip symbols. So again, the strike layers go parallel to the existing rock. So I'll put one here in layer 1 and on the right side in layer 1. And the dip points the way that the layers have been pushed, but probably an easier way is to look at this middle drawing and say, if it rained, which way would the water go? So the water is going to go towards the middle. It makes a gutter shape, a U-shaped, and so the water would go to the middle. Again, we realize there's not really rain here, and it's just a way to help us get the directions correct. So the dip points to the middle, on both layers. If we wanted to add another set of strike and dip symbols, we could. Strike going parallel to the existing layers, and in this case, dip pointing towards the center. And now as a last little part to this, we could color in to make it maybe a little more obvious to you. Again, it's the numbers and the strike and dip symbol that are the most important. If we had a geologic map, there would be colors. We've looked at geologic maps in class before, particularly when we looked at what groundwater can do to an area. But we can see on this one that the hot pink's on the outside edges for layer number 1, and the green is in the middle for layer number 3. So with our syncline, what we found is that the oldest layers are on the outside edge and the youngest layers are in the middle. And we've drawn our geologic map.